We're going to start 4-5. Again, the test is over for those who are listening in. The test is going to be over. If you go into 4-4 party, which should be part B, but it misspelled it, is this box right here. And then we also have the second fundamental theorem of calculus, which is basically saying the derivative of the integral is the original function. Okay, so here we go. We're going to do 4-5. All right. So far we've not been able to do many integrals. The only thing we know how to do is that guy. Remember, I told you there's no other rules. There's no power rule. I mean, kind of a power rule, but there's no product rule, quotient rule. Instead, we use what's called methods or tricks to integrate. Your first method that you're going to learn is called U substitution. Substitution. Okay. Here we go. This is the problems that we're going to be looking at. And we're going to start off simple. We're going to get harder and harder. And we'll look at a couple curveballs. X to the n? Yeah, this is the only thing we know how to do right now. That's it. That's our only rule that really bails us out. So here's the problem that we're going to be attempting now. Now we're going to jump back to indefinite integrals. We're not really going to plug in values right now. There is some homework tonight. I'll show you what that is. It's not a lot. We're going to split the homework over 2 nights. Okay? So I'm going to give you half tonight and half tomorrow night. It's only about 11. It's about 22 total. We're going to do 11 tonight. This is the problem we're after trying to do here. Now, we can do this one. We could FOIL out the big mess and then distribute my x through, and I'd get a nice polynomial. Okay? But we have a method to handle this. All right? It's called U substitution. What we've learned is that if I look at these two entities here, does anybody notice anything?
They have the same
Besides that, they have the same variable. Nope. Think in terms of calculus.
I don't know that. I don't know.
What? How are they related calculus-wise?
Product group? I don't know.
Do you see that x squared plus 1, when I differentiate that, do you see that it's 2x? And if I kind of hide the 2,
The two have the both.
the derivative of that is kind of sitting there. I'll say it again. The derivative of x squared plus 1 is 2x. Well, hide the number for a minute. Just pretend it's not there. Do you see that that is kind of the derivative sitting there? That happens quite a bit, and it's gonna help us solve this problem. So this is what we're going to do. We're going to do something called U substitution, and the first step, draw U.
Wow.
Okay? Next step, you got to pick the U. Sounds like a cheerleading cheer. You got to pick the U. Sorry. Here's how you pick the U. You think, what is the derivative of something sitting there? And so you think of the something. So in this case, what I'm going to let U be is x squared plus 1. Now, here's some general patterns in the universe. Generally, you let your U be is what's raised to a power. You usually let U be what's inside a radical. You usually let in trig functions, if it's like sine squared, you just let it be just the sign that's raised to a power, but just the sign. Okay. Now we're going to do a bunch, and you're going to come up with your own little patterns to figure out your U. All right. So here we go. Here's what we're going to do. You take this little U, and you have to do some scratch work. I'm going to differentiate everything with respect to x. So what's the derivative of U with respect to x? du dx. Okay. The derivative of U is 1, right? So it's 1 du dx. Okay. Equals, what's the derivative of x squared plus 1? 2x dx dx, so we don't write the differential. What you have to do is you have to get dx by itself. Nope, dx is sitting down here.
So put the U on the bottom.
So if you want, you can flip both sides. Hold on. Okay. Now, multiply both sides by du. So dx is du over 2x. Let me show you kind of a way that will always work, okay? Watch this. This is a process as a student and as a calc person. When you go to integrate this and do this, this is what you're going to do. You just immediately write 2x du over the derivative equals dx. Just do du every single time. The derivative of u is du, always. And just put the derivative of this in the bottom. Equals dx. Is that okay? Just always do it that process. That way you don't have to do all this algebra mess. It's always going to work out this way. Now watch what happens. I have x. X squared plus 1 is my u. So I'm going to write a u instead. What is dx? Du over 2x. The x's cancel. The 1/2 gets brought out front. Do you see how easy that is now? U squared. We know how to integrate u squared. It is u cubed over 3. Clean it up a little bit more. We get u cubed over 6. When you get down to that, go back to what your u was and go plug it back in. So the final answer is going to be x squared plus 1 cubed over 6. And don't forget your c, because it's an indefinite integral. Okay. Let's meditate on this, okay? And clear things up in your brain. Let's get things ironed out, and I'm going to give you some to try. Yeah.
How did x become 1/2 alpha?
So dx is du over 2x. See this dx? I substituted du over 2x. That 1/2 is a constant, and we can bring that out front. So that 2 there is this 2 here.
Okay.
It's
then you
1/2.
just canceled
The x's cancel. That's our goal, to get rid of all the x's. Guys, you cannot integrate until you have all u's and du's. If I still had x's hanging on for the ride, so how do you know you chose the wrong u? You still have x's hanging on for the ride. Now, if that does happen, don't necessarily think you chose the wrong u. That's a curveball, and we're going to show you how to handle that. And if that doesn't work, then you got to start over. Okay? But yeah.
So, you know how you switch like 2x and then flip it?
Yes, right here.
2x, yeah.
Yep.
Doesn't that mean that it's 2x and negative 1 alpha?
No, this isn't flipping.
Yeah, but Z, sorry, so big deal. 2x to the negative 1 power. Is that what you're saying?
Yeah.
Okay, well, let's go with that. All right, we got du 2x to the negative 1. Now what do you do with it? Yeah, let's go ahead and throw it back down to the bottom, and then we can kind of get things canceled and deal with it. Okay, because that's really not a 2. That's really a what? A 1/2. Okay, so it means the same thing. All right, so let's just kind of stay away from that, and let's just kind of keep it with normal exponents. All right, let me give you one to try, but I'm going to nudge you a little bit. I'm going to tell you what the u should be, and then the next one I'll let you do one where I won't tell you what the u is. So let's start with 5x squared, terrible looking 5, plus 1 quantity squared times 10x dx. So my question to you is, what do you think the u should be?
That 5x squared.
Why, Liv?
I don't know.
It just kind of like appears like it should be. A, because it's kind of got a squared on it. That happens 8.3 times out of 10, okay?
Oh.
All right, Z, what are some other things you notice?
10x is 5x squared becomes 10x.
The derivative of 5x squared plus 1 is 10x. So you see the derivative sitting there. So there you go. That's how you kind of figure out what your u is. All right, everyone take it and see how far you can go with it. And I'll leave the old problem up here just because sometimes you can learn by seeing examples.
Aw. Okay, yeah.
We're not letting back here.
You survived this exam.
Well, we already have one done. I think we should go.
We had this walk motion.
We would.
Oh my god.
Yes, you
I would
substitution.
have dropped out of the class.
Just substitute the U.
That's what
That's
she
the
said.
class. Go back. Go back.
Grab some here and like, there you go. That's
Wrong door. Wrong door.
Wow.
I was like, shoot, Z's sitting there. He's not gonna let me in. Yeah, today was normally chapel day, so normal I probably could have had 10 minutes with him at lunch, but all right, here we go. What do we get?
1 second.
Five.
Oh.
I'm not done.
Okay, good. All right, what I'm gonna do is I'll freeze it, work it out. Yep.
Why don't you just write it down? Write it down. You know, what if you're home and you're just tired?
I look into that.
Boom.
You know, what if you're like, oh.
Don't forget the plus C, guys.
Let's see how.
We need something else.
All right, it's okay. Well, we're going slow, guys. I'm not gonna rush this. I promise.
And my lady, that's I don't.
Oh, I didn't see the squares.
That's Kim.
Yep,
If I do
that's
that.
U squared. Yep.
Okay.
All right, guys. Let me give you another one.
Messes it up. It's fine. Just 1 minute.
No worries. Now, guys, could we have integrated this old school?
Yeah.
Yes, FOIL it out, times the 10x through it, and make it easy. All right? So it could work. But now I'm going to give you one that you cannot do it the old way. So this next one truly has to be done this way. Okay, I'll leave that kind of sitting there for those of you kind of finishing up. And those of you want to start, here we go. The problem is x squared times the square root of x cubed plus 1 dx. Now, there's no way I can clean that up. I can't get the x squared inside the radical. I can't FOIL them together. So this one you truly have to use our new method here. Okay, I'll leave the old problem just kind of as a template to follow. Grace, what do you think our U is going to be?
You got this, Grace.
You can do it, Grace.
X cubed plus 1.
Bam, that's it. Okay?
I both that.
So again, the pattern we notice is generally, I don't want to say always, the U is what's inside the radical. Okay? Notice, what's the derivative of x cubed plus 1?
Oh,
X squared.
3x squared. Ignore the 3. There's part of the derivatives out there. Okay? So that's another clue. So U is x cubed plus 1. All right, go to town here.
and too much room.
Kanto, use paper, please.
Ah, come on.
Do I need to get you a little whiteboard? Would that be better for you?
I really like writing on the
I know.
whiteboard.
When I was in college, I'd always find an abandoned classroom, and they'd have whiteboards going around the walls and stuff, and I always did my homework. And so, something about standing back and looking at it. No, as soon as I did the problem, I would go and copy it down. But sometimes one problem was 2 boards, and so no, we didn't have cameras and stuff like that back then. We never had phones. We didn't even have cell phones.
Back in time.
Yeah. I think when I was in college, the first cell phone was like this big. It was that big brick. So. But it was just nice. It was quiet. I could walk around. I never did homework at home.
Man, interactive.
Never did homework at home
Interactive.
because I would fall asleep or there was too many temptations to go do something. So I either did it at a restaurant, and because I won't sleep in public, so I'll just sit there.
Man, that's awful. People are like having to see it while you're like doing
I'd find a Denny's or something, and I'd go do my homework in a back corner, and it just there's no temptation to say, because if you're at home, your bed's calling your name, the TV's calling your name, the whatever's calling your name, and it's just I get distracted easy. I guarantee I'm ADD. All right, here we go. All right, hold on. I'll freeze. So if I rewrite this, you're going to have x squared square root. Now I would write it with 1/2 power. Okay, because we really don't integrate radicals. We integrate that. Okay, so now I'm going to freeze it back down. Keep it going here. You have any problems over there, George? You got this? Okay.
Wait,
I love George.
what's 1/2?
Yeah, I live on the exponent. I didn't come back on the right.
What's 1/2 plus 1/6?
3/2. Remember the trick for adding fractions, adding window of fraction?
And that's something
Add the two numbers, 5 over the denominator. Okay.
right?
That's a 9, yeah. All right, if I want to add 1 to 17/13, what is that? 30 over 13. Add them over the denominator, okay? So that's how you add 1. Anytime you want to add 1 to a fraction, add the two numbers and stick it over the denominator. Yeah.
Is there a way to do that if you have like, I don't know, like 16 over 13 and then like
16 over 13 plus 1 will be what?
No,
29 over 13.
without the one. Like if you have another number is not one.
No, it only works with 1.
Wait,
All right, here we go. Let's talk it through.
oh,
So my u is x cubed plus 1, so I get du over 3x squared equals dx. So here I have x squared, u to the 1/2 times dx. I put that in, my dx is this. The x squares cancel. And I have this 1/3 sitting here, so that's why that's out front. So now I'm just down to this. And now it's easy. Now we're home free. The integral of u to the 1/2 is u to the 3/2. Here, let me show you what I do to these, okay? You add 1 to the power, like I just said. 1/2 plus 1 is 3/2. Get in this habit, guys. When you have a fraction in the denominator, you write it and throw the denominator to the top. It works out, trust me. But if you get into that pattern, you don't even have to think about it. All right? And then I just clean this up. 2 kings on for the ride. 3 times 3 is 9. And then that really means the square root of u cubed. And then now I'm done. I just put my u back in, which is x cubed plus 1. Okay? All right, let me give you another one. One more, and then I got to show you a curveball. Let's do a trig one. We love trig in this class. Trig is our friend. Yes.
The pre-calc kids just took that trig test, and they all did like really well. They were like, "This is like so easy," like all stuff, and I was like, "Just wait." And then wait, okay, last.
But what part of trig? Trig is a very broad topic.
About pre-calc, and they all were like, "Shut up!" And then now they're all like complaining about it. And I'm like,
Mhm.
Now you know how I feel. That's right.
Oh
No,
no,
they
it
all
was
feel bad,
probably
like-
the trig where you just had to like make it different.
Opposite
like,
of
make it all-
hypotenuse. Yeah.
Yeah, like make it all like sine and cosine. Just
Listen,
make it-
trig is very broad. You can make an entire year-long course out of just trig.
Yeah, I used to love trig.
Did y'all get into polars?
I don't.
I remember touching on it.
Polar coordinates? Okay. All right. So, I mean, there's a lot to trig stuff. All right, here we go. What's the U?
Tangent squared x secant squared x.
No, that's the whole problem. What do you let your U be?
Tangent squared x is
Grace is on it, man. What's U, Grace? Tan of x.
oh JK.
Oh, sorry. I didn't hear the secant part. Why? Why? Think it through.
Because
What is the derivative of tan?
Secant x secant
Secant squared.
squared.
And look, it's sitting there all by its lonesome self, okay? So here we go.
I don't
du.
know which one to base it off of.
Well, what's secant? All right, let's pretend we did something bad. Let's go through this choosing the wrong U. Let's see the walls we're going to run into.
The U with the tangents. Yeah.
Hold on. Let's choose the wrong U. So
What's
this
the derivative of
well, the derivative of secant is secant tan. Okay, so I'd be over secant
oh, that's why.
tan equals dx. Here we go. Watch what happens. I kill one of the tans, but I'm still left with a secant of x and a tan of x. That's the wall you run into. In order to make this work, I have to get rid of everything, and I just need u's left over. So I would stop right there, erase. Okay, so I always say right light and try another u. Okay, let's. All right, so here we
The
go.
U's are always like simple, right? Like 10 of x or never 10 of x squared.
You don't know. You've gotta. It takes experience to get better at choosing the correct U. These are very simple right now. There are some difficult ones in here. Okay, that's why we're going to spread it out and do about 20 to 30 of them. And I think you'll get it by then, all right? So here we go. So this is U squared, secant squared of x. Dx is du over secant squared of x. Now you can see they're gone. So what's the integral of U squared? U cubed over 3. Put your U back in. There we go, guys. Okay? All right, homework. Go into the 4-5, not the 4-5 again. I copied it so you don't have to take your book home. It's 5 through 26 on page 341. I'm just giving you the odds, okay? 5 through 26. Should be through 25, my bad. I'm still learning math here. 5 through 25 odds. I threw the answers in for you. Okay? So you can check your work. I know the answers are probably in the back of your book, but we're going to do evens tomorrow. So